This is VAP 6, question 20 of section 8.2, and this is the derivative graph of a function, and we are trying to find the parent function given the initial condition f of 0 is equal to 2 in the domain from -2 to 4. And we can do this using number lines, and we can find the slope of the original parent function by the values that the function gives us. But first we can use the zeros of the derivative equation to find the maximum and minimums. So there is a 0 at -1, a 0 at 1, and a 0 at 3. And from -2 to -1, the values are negative, so the parent function would be decreasing from -1 to 1, it's increasing, 1 to 3 it is decreasing, and 3 to 4 is increasing. So kind of have a general feel of what the graph will look like slope-wise. And we can use the second derivative of this graph to find the concavity of the parent function. So from -2 to 0, there's a concavity up, and these dashed lines are just to show when it ends. From 0 to 2, there's concavity down, and from 2 to 4, there's concavity up. And from here, we are trying to find the integral of this graph, and how we can find the integral for this is using finding the area under the curve for this for the parent function. So what we can do is, well, we know it starts at 0, 2, and we can estimate that by counting squares that this is about 0.3. So we would raise, so at 1, 2.3 would be the next point, and we do that for all of the points. So the next one looks like it lowers about 0.3 as well. This one looks about 0.3, so it'd go to 1.7, and this one has a great increase. It looks about over 1. And then you do it for the same side, or for this side, but these values would be negative. So this would be subtracting 0.3, and this, since this is negative, this would already be negative, and it's already going underneath the x, the x line. It would increase. So the graph would look like this.